Let us continue exercise 7.2, page number 305. We will do question number 20 first and then we will do 19th one. In question number 20, we will take the denominator as t. Let us differentiate. Differential of e raised to 2x is e raised to 2x into 2. You have to apply chain rule. E function has to be differentiated first, so e power 2x, and 2x has to be differentiated, which gives you 2. Similarly, differential of e power minus 2x is e power minus 2x into minus 2. Dx is equal to dt. 2 is common. We have e power 2x minus e power minus 2x dx in the numerator, which becomes dt by 2. So the numerator becomes dt divided by 2 and denominator is t. Integration is so easy to do, which becomes log of absolute value of t. Substitute for t. Half into log of absolute value of e power 2x plus e power minus 2x plus c. No need to write the absolute value sign because e function is always a positive function. Always it is greater than 0. And we have plus sign in between. Therefore, no need to write the absolute value sign. Now let us do question number 19. Integral e power 2x minus 1 divided by e power 2x plus 1 dx. Here, if we take the denominator as t, we get only e power 2x into 2 dx, which is dt. But we have minus 1 also extra term in the numerator. Therefore, we will bring this function to the 20th form. See the 20th question. Let us bring it to that form. So to do so, we will divide by e power x. Each and every term is divided by e power x. E raised to 2x by e power x is e power x minus 1 by e power x divided by e power x plus 1 divided by e power x dx. Let us write this as e power minus x Now this question has become similar to the 20th question. Let us substitute the denominator as t. Differentiate. Differential of e power x is e power x. Differential of e power minus x is e power minus x into minus 1 dx equal to dt. Therefore, the numerator becomes dt and the denominator is t. The integration is log of absolute value of t plus c. Substitute for t and we know that e function is greater than 0. So we need not write the absolute value sign. We have plus sign in between. So let us remove the absolute value sign. Log of e power x plus e power minus x and plus c. Question 21. Integral of tan square 2x minus 3 dx. We have direct integration formula for secant square. We don't have for tan square. So let us use the identity secant square theta is equal to 1 plus tan square theta and change tan square to secant square. It becomes secant square 2x minus 3 minus 1 times dx. Now we can integrate and write integral of secant square is tan of 2x minus 3 and divide by the coefficient of x. Since this is a linear function of x, direct application of the formula is possible. If it is not a linear function, then you cannot use the formula directly. An integral of 1 is x and plus c. Since it is a linear function, no need to use substitution. Directly we can do it. Question 22. Secant square 7 minus 4x dx. For secant square we have direct formula, and this is a linear function. So direct formula is applicable. Integral of secant square is tan of 7 minus 4x and divide by the differentiation of that 7 minus 4x, or divide by the coefficient of x, which is minus 4. So this is the coefficient of x term. Don't forget to do this. Question 23. Integral sine inverse of x divided by root of 1 minus x square. So simple it is. We know that differential of sine inverse of x is 1 by root of 1 minus x square. So let us substitute sine inverse of x as t. Differentiate both sides. Now substitute dx by root of 1 minus x square becomes dt, and sine inverse of x is t. Integral of t is t square by 2 and plus c. Substitute for t. Sine inverse of x the whole square divided by 2 and plus c is the answer. To do these questions, you should be thorough with all differentiation and integration formulae, and you need practice. 24th question. 2 cos x minus 3 sin x divided by 6 cos x plus 4 sin x dx. In the denominator there is 2 common. Let me remove that 2. 2 cos x minus 3 sin x divided by 2 is common, which is 3 cos x plus 2 sin x into dx. Now I will substitute 3 cos x plus 2 sin x as t. Differentiate both sides. Differential of cos is minus sine, so it becomes minus 3 sin x plus 2 times cos x into dx is equal to dt. 2 can be removed outside. The numerator, we have the same term in the numerator, which becomes dt divided by the denominator is t. Integral of 1 by t is log of absolute value of t, and substitute for t, so half log of absolute value of 3 cos x plus 2 sin x and plus c. Here we cannot remove the absolute value sign because we don't know whether cos and sin are positive or negative. Question 25.
Integral 1 divided by cos square x into 1 minus tan x the whole square dx.
I can write 1 by cos square as secant square x divided by 1 minus tan x the whole square dx. We know that differential of tan x is secant square x. Let us substitute tan x as t. Differentiate both sides. Secant square x dx is dt. Therefore the numerator becomes dt and the denominator is 1 minus t the whole square. And 1 minus t is a linear function. Let us write this as 1 minus t the whole power minus 2 dt, and use x power n plus 1 by n plus 1 formula because this is a linear function. That's how we could use the formula. So it becomes 1 minus t whole power n plus 1. So minus 1 divided by minus 1, and don't forget to divide by the coefficient of t. This is 1 divided by 1 minus t plus c. This minus 1 is the coefficient of t. And substitute for t, the answer is 1 divided by 1 minus tan x and plus c. Question number 26. Integral of cos of root x by root x dx. We know that differential of root x gives 1 by root x. So let us take root x as t. If you take cos of root x as t, we will get minus sine root x, which is not there in the function. So we will take only root x as t, which is x power half. Differentiate both sides. Half into x power half minus 1 becomes minus half. N into x power n minus 1 differentiation formula. Dx by root x becomes 2 dt. We have dx by root x. It becomes 2 dt, and here it is cos t. Remove 2 outside the integral and integrate cos t. Integral of cos t is sine t, and substitute for t. T is root x. So 2 sine of root x plus c. Question 27. Integral of root of sine 2x into cos 2x dx. Since we have cos 2x dx, we will substitute sine 2x as t, or we may substitute root of sine 2x as t. We can avoid the fractional power by substituting root as t. Let us remove the root sign by squaring both sides. Differentiate both sides. Cos 2x into differential of 2x is 2, dx is 2t dt. Cancel 2. Let us substitute. This is t and this is t dt, which is t square. Integral of t square is t cube divided by 3 and plus c. Substitute for t. Sine 2x power 3 by 2. Root can be written as power half, and plus c is the answer. Question number 28.
Integral cos x divided by root of 1 plus sine x dx.
We can substitute sine x as t, or 1 plus sine x as t, or root of 1 plus sine x as t. Square both sides. Differentiate. Differential of 1 is 0, so we get cos x dx is 2t dt. Let us substitute. The numerator becomes 2t dt and the denominator is t. It becomes integral of 1 dt, which is 2t plus c. Substitute for t. 2 times root of 1 plus sine x and plus c. Question 29. Integral of Cortex into log of Sine X dx. Differential of Cortex is minus cosecant square. We don't have. So let us try by taking log of Sine X as t. Differential of log is 1 by Sine X. We are applying chain rule. Then differentiate Sine X, which is Cos X dx. We get Cortex dx as dt, which is there in the function. Cortex dx is dt and log of sine x is t. Now integrate t square by 2 plus c and substitute for t. So log of sine x the whole square divided by 2 and plus c. For trigonometric functions, we can write square in between like this. Sine x the whole square can be written like this. But for log function, if it is whole square, we have to write whole square. We cannot write it as log square x. We don't write it. Okay, only for trigonometric function we write it like this. Question 30. Integral of sine x divided by 1 plus cos x. It's a very simple question. We know the differential of cos x will be minus sine x, so let us substitute the denominator as t. Or you may take only cos x as t. Differentiate 0 minus sine x dx is dt. Therefore, the numerator becomes minus dt. Divided by t. Minus can be taken outside the integral, and integral of 1 by t is log of absolute value of t. And substitute for t, therefore the answer is minus log of absolute value of 1 plus cos x plus c. Question 31, it's just exactly the same type. Here also we use the same substitution, 1 plus cos x as t. Differentiate both sides. Sine x dx is minus dt. Let us substitute. The numerator becomes minus dt and denominator is t square, which can be written as minus integral t raised to minus 2 dt. Use x power n plus 1 by n plus 1 integration formula. So it becomes minus 2 plus 1, which is minus 1 divided by minus 1 plus c. Minus of minus is plus, and substitute for t. Question 32. Integral 1 by 1 plus Cortex dx. Questions 32 and 33 are of same type. Put a star in your textbook for this question. You have to remember the method. Let us write cot as cos x by sine x and take LCM. Sine x plus cos x, and the denominator can be written in the numerator. Now multiply and divide by 2. Therefore we get 2 and half outside, 2 sine x divided by sine x plus cos x dx. And let us write this numerator 2 sine x as sine x plus sine x. Sine x plus sine x is 2 sine x. And I am going to add cos x and subtract cos x. So that we will have the numerator here, and here this is the differential of the numerator. Now let us separate the terms. First term divided by the denominator becomes 1, and then the second term divided by the denominator. So this has to be done by substitution. Let us substitute the denominator as t, because differential of this is there in the numerator. Differential of sine x is cos x, and this is minus sine x dx is equal to dt. Take minus sign out. Half into integral of 1 dx plus, the substitution is only for the second term, integral, the numerator becomes minus dt and the denominator is t. Let us integrate and write half into, the integration is done with respect to x, so integral of 1 is x, minus integral of 1 by t is log of absolute value of t plus c. Substitute for t, sin x plus cos x. Therefore, the answer is half of x minus log of absolute value of sin x plus cos x and plus c. Question number 33, exactly same as question 32. Same method we are going to follow. Let us change tan to sine by cos. Take LCM. Cos x minus sin x. That LCM goes to the numerator. Cos x dx. Let us multiply and divide by 2. Cos x divided by cos x minus sin x dx. We are multiplying and dividing by 2. Now the numerator 2 cos x can be written as cos x plus cos x. Now I will subtract sin x and add sin x, so that this is the denominator and this is differential of the denominator, divided by cos x minus sin x dx. Let us separate the terms. Cos x minus sin x divided by cos x minus sin x is 1, and the second term is cos x plus sin x divided by cos x minus sin x dx. So the first integral is 1 dx and the second integral is cos x plus sin x divided by cos x minus sin x dx. Now this has to be done by substitution, the second integral. Let us substitute cos x minus sin x as t. Differentiate. Differential of cos x is minus sin x and differential of sin x is cos x dx equals dt. Minus sign can be taken out. Therefore, it becomes half into integral 1 dx plus, substitution is for the second integral. The numerator is minus dt divided by the denominator is t. Half into integral of 1 with respect to the variable x. If it is integral of 1 dt, the answer should be t, because integration is done with respect to t here. But here we have dx. So the answer is x minus log of absolute value of t plus c. Substitute for t. So the final answer is this. Question 34. This is an important question. You should remember the method for this. Put a star in your textbook. Integral root of tan x divided by sin x into cos x dx. Let us divide both numerator and denominator by cos square x. So we get root of tan x divided by cos square x, and in the denominator sin x cos x divided by cos square x dx. Here I can cancel one cos x, and in the numerator 1 by cos square can be written as secant square x divided by, denominator is sin x by cos x, which is tan x. I can further simplify. Root tan x and tan x could be simplified, and it becomes secant square x divided by root of tan x. Now we have a perfect combination, tan x and secant square x. We know that differential of tan x is secant square x. So we will substitute tan x as t or root of tan x as t. Square both sides to remove the root sign and differentiate both sides. Differential of tan x is secant square x dx. The other side is 2t dt. Therefore the function becomes, the numerator is 2t dt divided by t. 2 is a constant, so 1 dt. An integral of 1 is t. With respect to t, we are doing the integration. dt is there. Now substitute for t. So 2 times root tan x plus c. Question 35, integral of 1 plus log x the whole square divided by x dx. We know that differential of log x is 1 by x. So we will substitute 1 plus log x as t. Differential of 1 is 0. We can substitute only log x as t also, but it is better to take 1 plus log x. So 1 by x dx is dt. We have 1 by x dx, which becomes dt, and this becomes t square. This is t cube by 3, and substitute for t. 1 plus log x the whole cube plus c. Question 36. Integral x plus 1 into x plus log x the whole square, whole thing divided by x dx. I can write this as 1 plus 1 by x, that is I am dividing by x and writing, into x plus log x the whole square dx. Let us try with x plus log x as t. Differential of x is 1, differential of log x is 1 by x, which is there in the function. So 1 by x dx becomes dt, and this bracket is t square. So integral of t square is t cube divided by 3, and substitute for t. X plus log x the whole cube divided by 3 and plus c. Question number 37. Integral x cube sine of tan inverse of x power 4 divided by 1 plus x raised to 8 dx. Let us substitute tan inverse of x power 4 as t. Differentiate. So to differentiate, you have to apply chain rule. Tan inverse has to be differentiated first, and then x power 4 has to be differentiated. Differential of tan inverse is 1 by 1 plus square of x power 4, which is x power 8, into differential of x power 4 is 4x cube, chain rule. Differentiate tan inverse first and then differentiate x power 4. dx is equal to dt. Therefore, x cube divided by 1 plus x raised to 8 dx is dt divided by 4. We have this here. So this becomes dt divided by 4 and sine of tan inverse of x power 4 is t. Now see how simple the function has become, which is very easy to integrate. An integral of sine t is minus cos t plus c, and substitute for t. The answer is minus 1 by 4 cos of tan inverse of x raised to 4 and plus c. Question 38. It looks like a difficult question, but it is a very simple question. This is log 10 to the base e. It should be written like this, divided by x raised to 10 plus 10 raised to x dx. Take the denominator as t. Very simple. Directly you get the numerator. Differential of x power 10 is 10 into x power 9. And differential of a power x is a power x into log a, we know. Here a is 10. So it becomes 10 power x log 10. If base is not written in our NCERT textbook, it means it is to the base e. Dx is equal to dt. Exactly the same thing is there in the numerator, which becomes dt, and the denominator is t. Therefore, the answer is log of absolute value of t plus c, and substitute for t. Therefore, log of absolute value of x raised to 10 plus 10 raised to x and plus c. The correct option is D. Again, this is a positive function. X power 10. 10 is an even number. Whether x is positive or negative, x power 10 is positive. And 10 power x is also a positive number, whether x is positive or negative. For example, x is minus 2, say. So 1 by 100, which is positive. So both are positive values. And you have plus sign in between. So no need to write the absolute value sign. So the correct option is D. Question 39. Integral dx divided by sine square x times cos square x. This can be written as 1 divided by sine square x times cos square x dx. Now let us replace this 1 by the identity sine square x plus cos square x divided by sine square x times cos square x dx. Now let us separate the terms. So the first term is sine square x divided by sine square x multiplied with cos square x dx, plus the second term is integral cos square x divided by sine square x times cos square x dx. Let us simplify. Integral 1 by cos square is secant square x plus integral 1 by sine square x is cosecant square x dx. We have direct integration formulae for both. Integral of secant square is tan x and integral of cosecant square is minus cot x plus c. The correct option is B. See example 6. You practice the third subdivision. The third subdivision, 1 by 1 plus tan x, is similar to questions 32 and 33. Follow the same method and do subdivision 3. Now let us do second one. Integral of sine x divided by sine of x plus a dx. If you expand the denominator using sine a plus b formula, you will have two terms in the denominator. We cannot separate the terms. We will substitute x plus a as t. Differentiate both sides. A is a constant here. Sine of x is t minus a. And here denominator becomes sine t. Dx is dt. Now use sine a minus b formula in the numerator. So it becomes sine t cos a minus cos t sine a divided by sine t and dt. Let us divide each term by sine t. Sine t will get cancelled. The first term becomes cos a. And then the second term, cos t divided by sine t, becomes cot t and dt. A is a constant. Therefore, sine a and cos a are also constants. Don't integrate cos a and write it as sine a. We will take it outside the integral, so it becomes 1 dt, and sine a is also a constant. Take it out. Integral cot t dt. Cos a into t minus sine a. Integral of cot is log of sine t plus c. Let us substitute for t. T is x plus a into cos a minus sine a times log of sine of x plus a and plus c. I can open these brackets. X cos a plus a cos a minus sine a into log of absolute value of sine of x plus a and plus c. Now this is a constant. I can combine these two constants and write the final answer as x cos a minus sine a into log of absolute value of sine of x plus a, and c plus a cos a can be written as some other constant c1, where c1 is a cos a plus c. Example 5. We'll do the third subdivision. Integral tan power 4 root x secant square root x divided by root x dx. We know that differential of tan is secant square. So we will substitute tan of root x as t. Tan and secant square combination is the best combination. We will go for substituting tan x as t. Let us differentiate using chain rule. First we have to differentiate tan, then we have to differentiate root x. Differential of tan is secant square root x, and differential of root x is half into x power half minus 1, which is minus half. Dx is equal to dt. This is secant square root x divided by x power minus half can be written as root x in the denominator, 2 dt. I have taken 2 to the other side. Let us substitute. We have these 3 here, which becomes 2 dt. And tan root x is t, so t power 4. So simple the function has become. The integration is t power 5 by 5 plus c and substitute for t. T is tan root x power 5 and plus c.